All right, so today we're going to dig into something kind of wild. We're talking about plants that don't just, like, tolerate metals, but they actually collect them. You know how plants need iron from the soil? Basic stuff.
Right.
This picture we're looking at, it takes that to a whole other level.
Yeah, it really does. It's called hyperaccumulation, and let me tell you, it's seriously fascinating stuff.
So we're not talking, like, just a little extra iron in the leaves here, right?
No, no, not at all. This 1989 research, it lays out some specific numbers. We're talking over 1,000 micrograms per gram for metals like cobalt, copper, even lead. That is way beyond what's considered normal, even for plants that are in naturally metal-rich areas.
So it's like some plants have this secret superpower to just suck up these metals that could just completely kill other plants.
Exactly. And what's interesting is that this research paper, even back then, they recognized how significant this was. They weren't just looking at, slightly elevated levels. We're talking concentrations that are orders of magnitude higher. It really challenged what people knew about how plants work, plant physiology.
So let's say I wanted to find these metal-hoarding plants. Where would I even begin to look?
Well, get ready for a global treasure hunt because this paper, it actually includes these distribution maps.
Oh, cool.
And what's fascinating is you won't believe some of the places these plants pop up. They're not just anywhere. They're tied to very, very specific soil types. Soils derived from these things called mineralized ultramafic rocks.
So we're not talking about your average backyard garden here. These things are
No.
thriving in some pretty extreme places.
Absolutely. And that's part of what makes this research so compelling because it just shows how life, even plant life, can adapt and thrive in conditions that most would consider completely inhospitable.
Makes you wonder what other secrets are out there just hidden in plain sight. This research paper, though, it reads like a who's who of the plant world's most, like, extreme eaters.
It really does.
Was there any particular example that really jumped out at you?
Oh, there are several. But take, for instance, Ailanthus biformifolius, a plant from Africa. This thing stores such high concentrations of copper in its corms that it was, at the time of this paper, the highest concentration ever documented in a vascular plant.
That's wild. Yeah. And what I find even more fascinating is it's not just that they're storing these metals, but they're doing it without, dying. Like, how do they do that? What did the researchers find out about how they survive that? So they're able to just, like, store these metals. How do they do that? It's like they've got some kind of internal alchemy going on, turning toxic metals into, well, something they can use.
It really is remarkable. And this paper, it delves into the fascinating world of plant physiology to explain exactly that. Essentially, it comes down to two key things. Their incredible tolerance to high metal concentrations, and then this unique phytochemistry, basically the chemical compounds that they produce.
Okay, so let's break that down a little. Let's start with the tolerance. How much metal can these plants actually withstand?
Well, the paper, it actually mentions experiments where they subjected certain species, like they talk about Hominiastrum catagens, to levels of metals that would just be lethal to most plants. And these hyperaccumulators, they just kept growing.
Wow. So it's like they have, like, this internal metal shield,
Yeah.
but how do they actually neutralize the toxicity? That's where the phytochemistry comes in, right?
Exactly. They've evolved this really clever defense mechanism where they produce organic acids, things like citric acid, which actually bind to the metals, so it forms this sort of protective complex.
Oh, interesting.
Yeah, and this process, it's called chelation. It's what prevents the metals from actually causing damage inside the plant.
So they're not just storing the metal, they're, like, actively neutralizing it. It's like they have their own little internal detox squad going on.
Yeah, that's a great way to put it.
It makes you wonder, like, why go through all this trouble? Why evolve to not just tolerate, but actually thrive in these really challenging environments?
That is the million-dollar question, isn't it? And you know what? This paper, even back in 1989, they recognized that this wasn't just some scientific curiosity. They saw the potential in these plants, even hinting at some possible applications that could have, real-world implications.
Okay, so you're saying these metal accumulating plants, they're not just fascinating anomalies, they could actually be useful.
Exactly. The paper specifically talks about two really promising applications. One is phytomining, and the other is soil detoxification.
Phytomining. That sounds intriguing. So are we talking about, like, plants becoming miners here?
In a sense, yeah. Imagine cultivating plants like that Cibertia acuminata we talked about, the one with the nickel-rich sap, on land that has low-grade nickel ore.
Okay.
They would essentially soak up the nickel, you harvest the plants, and then you extract the metal from the plant material.
So it's like almost a more like eco-friendly way to mine,
Yeah, right.
using the power of nature instead of all this heavy machinery.
Exactly.
And what about soil detoxification? How would that work?
So picture this. You have a site that's contaminated with, say, heavy metals. You could actually grow these hyperaccumulator plants there, let them do their thing, absorbing the contaminants, and then safely remove them.
So it's like a form of bioremediation almost.
Exactly. Bioremediation using plants. And the paper actually cites a real-world example of this. They talk about Hamaniastrum catanense, remember our cobalt-loving friend?
Yeah.
They were actually using it in the U.S. for radioactive cobalt cleanup.
Wow.
Yeah, so it just goes to show, the potential of this is huge.
That's incredible. So these plants, I mean, often they're dismissed, right, as just weeds,
I know, right?
but they could hold the key to actually cleaning up our planet.
It's amazing. It really highlights how everything is interconnected, And the natural world, it holds these solutions that we might not even be aware of yet. True. And it really makes you appreciate those intricate workings of nature, like the possibility of finding solutions in the most unexpected places. So this paper, it focused on plants that accumulate some pretty common metals, like at least in this context, but it got me thinking, could there be plants out there that are amazing at accumulating rarer metals, maybe even more valuable ones?
That's a really interesting question.
Could you imagine?
It speaks to just the vast untapped potential of the plant world.
Yeah.
I mean, if we're finding plants that are this good at accumulating nickel, cobalt, even radioactive elements,
Right.
who knows what else might be out there?
It's like something out of science fiction. Imagine, could there be a plant that accumulates gold
Yeah.
or platinum? Could you imagine stumbling on a field of those?
It might sound far-fetched.
Yeah. But, I think this research really underscores the importance of keeping an open mind because there are so many plant species we haven't even fully investigated yet. So many ecosystems we're just beginning to understand.
It really is incredible when you think about it. This whole deep dive has just totally opened my eyes. We've gone from basic plant nutrition to this wild world of hyperaccumulation and uncovering this hidden potential in these plants. It's amazing.
Yeah, it really highlights that importance of scientific curiosity, right?
Absolutely.
And just the power of observation. This 1989 paper, even decades ago, they recognized that what they were looking at had some big implications, and it's something that we're still exploring today.
It makes you really appreciate those intricate workings of nature, like how there's the possibility of finding solutions in the most unexpected places. So I guess next time we see a plant, that we might just dismiss as a weed, maybe we should take a second look.
Yeah.
Who knows? Maybe it's a metal collecting marvel in disguise. Well, thanks for joining us for this deep dive into the world of hyperaccumulation. It's been quite a journey.
It has.
Until next time, keep exploring.